Okay, when you're doing this question, just understand what is going, like very likely there's a conditional probability going on. So you try and identify the events. Typically there are two events. Okay, so a certain disease is present in 1 in 20. So disease being present is 1 in 20, meaning this is universally that is the case. So in a mass screening program, a quick test for disease is used, but the test is not totally reliable. Okay, so like any test, there's always like a false positive or false negative. So you just have to be aware of it and then just have to mitigate it. So that's the idea. For someone who does have the disease, there is a probability of 0.9 that the test will prove positive. You see, there's a disease, or whether one case is having a disease and the other case is whether the test is positive or not. Okay, so I'm going to write these two events down before we even start. The positive I cannot let P because I keep writing P, then it's very confusing. So just let T be the test being positive. You have to be able to write these two down first because you need to label them. So for example, for this 1 in 200, what is this? This is P what? P? D is equals to 1 in 200. The entire population, because there's no condition. So meaning you know that this is 1 200. Okay, so that's 1 in 200. So then in a mass screening program, a quick test for the disease is used to then it's not reliable. For someone who does not have the disease, now this is the prerequisite. Someone who does not have a disease, so meaning to say this is what? D prime, right? There's a probability that there's a 0.9 that the test will prove positive. Well, this test is lousy, man. This test is lousy. If you do not have a disease, you get prescribed the wrong medicine. You have 90% chance of cannot diagnose you're positive. No, this is not a test, bro. This is a scam. Yeah. So this is the sell you drug, get you pay more money to buy drugs kind of scam. You don't want that to happen. If someone does have the disease, sorry, I read wrongly. Someone does have the disease, sorry. Someone does, yeah, then it's okay. So does have the disease, that is 90%. So this is okay. So essentially, this is what? Probability of test positive given that if you have this is 0.9. Okay, write it down. So PD is 1 in 200. Then P T given have the disease is 0.9. Okay, it does have the disease. Then after that, whereas for someone who does not have the disease, so meaning to say this is D prime, then this is correct. Then this is a reliable test because only 2% will prove positive. So this is false positive. So this is P test is positive when D prime. Copy down, label all the diagram. Now, just to recap, this is obviously PD, right? This is what? P, T given D happen. This branch is not PT, this is PD given D already happened. Then this is PD prime. This branch is P test positive D prime. So just label them. So this will be, the one you label is 1 in 200. Is 199 in 200. Okay. Then this guy will be P, this is 0.9, 0.1. This is 0.02, 0.98. Find probably that the person has disease and test positive. So you want to have a disease and test positive. So you just want P, D intersect T. Okay, once you have a tree diagram, you can tell this will then be disease and test positive, or this one. 0.9 times 1 over 200. Okay, because this is D, this is T. You multiply them, you get the the intersect between the two cases. Okay, fine. So part 1, 2 done. Test is negative, meaning you say you want PT prime, right? Part 3. PT prime will be you just add everything which have T prime. Part of the T prime will be in the disease group, and then part of the T prime test negative will be in the non-disease group. So you just add both this probability together. So it's add these two branches plus 199,200 times 0.98. That. Given that the test is positive, given this already happened, prerequisite, find a probability that the person has the disease. So D lah. Okay, that's that. So you just part 3, part 4. Okay, so this is it. You get this as use formula lah, PD intersect T over PT. Okay, PD intersect T will be this guy you found just now, 9 over 2,000. PT will be 1 minus PT prime, which is this guy we found just now. Okay, there you go. So look at last one. People for whom test positive, who proves positive, it doesn't matter whether it's false positive or the actual positive, are recalled and retested lah. Find a probability that a person has the disease if the second test is also positive. So this is a conditional probability, right? This is what I'll do. I'll explain the tree diagram. When you solve probability questions, you have 3 options to solve. You can either solve a Venn diagram, tree diagram, or probability outcome diagram, at least as far as your syllabus is concerned. So these are the 3. So now, if these people who are tested positive will get recalled, right? It's only these two branches here, right? You just need to extend this branch here. Am I right to say? Okay. So test positive, then you'll be called back to carry out the test. If you are recalled, you recall back. This is the first test. Second test is here. So test positive, then test negative. Then test positive, test negative. The probability that you'll get is still 0.9 and 0.1, right? This is 0.02 and 0.98 because you are still under the same not disease and disease group. Okay, so you just need to copy is independent of the first test. It's a conditional probability if the second person also proved positive. So second test is positive. Probability the person is diseased. This information here, the first test positive, right? Recall and tested, right? It tells you to only branch out these 2 branches. Okay, so that's why you have that 2 branches. So this one is just diseased. Second test positive. Overall, second test positive. Okay. Okay, as a data analyst, you want this probability to be as high as possible or to be as low as possible. If you call somebody come back, you jab him twice. Zap. Okay. They are both the second test is positive, right? You want the chances of the person tested disease, you want it to be higher, right? The better, correct? Because if then you jab that person twice, then the person disease is just check, right? Yeah, you want this to be higher, right? You want to be sure. So you just test. Second test positive will be quite okay. Second test positive will mean this, right? This guy. Now, when you do conditional probability, if you're confused, always do the condition first. Okay, because oftentimes the cases on top comes from below. Okay, so second test positive will be this guy here. This second test is positive, and this guy here. Understand? So essentially, what you need is 1 over 200 times 0.9 times 0.9 for the first case. Second case is 199 200 times 0.02 times 0.02. Okay, now then the case on top, disease intersect with second test positive will be the disease is second test positive, this guy. Okay, so like I said, the case on top always come from the below. Okay, the case on top will always you can always find the case on top from the denominator. That's what it's called restricted dom. You look at only the case which happens before. Okay, so just key this in. Okay, that's it.